Have you ever wondered how complex the working of a CPU is? How a CPU along with a RAM works on multi-programming? Let us see how CPU scheduling actually works. Okay, so let's get started. So what is actually scheduling? Scheduling is a method which is generally used in multi-programming system to improve the CPU utilization or to keep the CPU as busy as possible. Okay, like we know that CPU performs a lot of tasks at a single time. So how does it actually do it? It does it with the help of scheduling. So what is scheduler? Next comes. It is a program which is provided by the OS to support the multi-programming method or technique. So a special program is being provided by the OS to support the multi-programming technique that is known as scheduler. Then comes the type of scheduler. These are the long-term scheduler, the medium-term scheduler and the short-term scheduler. For a better understanding, let us see the entire flowchart. First we have job pools. These are the jobs which are waiting to get into the RAM for their execution. Next we have the ready queue. Ready queue is there inside the RAM in which there are all the jobs which are ready for execution. So the jobs in the job pool wants to enter into the ready queue. Then we have the CPU which actually performs the execution on the jobs received from the ready queue. Okay. So long-term scheduler, what does it do? It actually selects the jobs from the job pools to enter into the ready queue. While short-term scheduler, what does it do? It actually assigns the jobs from the ready queue to the CPU for execution. Okay. And what does medium-term scheduler do? It is used for swapping out. We'll just see shortly what is swapping out. Okay. Next we have the input-output interrupt. So if a job is executed by the CPU and suddenly some input-output request comes, that is known as input-output interrupt. So in that case, the execution of the job is interrupted, okay, and the job goes to the waiting queue. And after the input-output execution, the job returns back from the waiting queue or from the ready queue to the CPU for its further execution. Okay, so then comes, let us see what is long-term scheduler. It is a program which is used to select the processes which are ready to come in the ready queue. As we have already seen that the jobs or the programs are to be transferred from the job pool to the ready queue. So that is the duty of the long-term scheduler. So it controls the degree of multi-programming. That is how much program should enter into the ready queue. That is decided by the long-term scheduler. Then comes, it is also responsible for selection of proper mix-up of CPU bound process and input output bound process. Like there should not be too many CPU bound processes, otherwise they would consume the entire resources. Also there should not be many input output bound processes because they would just unnecessarily keep on interrupting. Okay, so there should be a proper mix of CPU bound process and input output bound processes. That is done by the long-term scheduler. So it is also called as job scheduler because it selects the job from the job pool. Then we have the CPU bound process. So these are those processes which are mainly involved in execution. Okay. And what are input output bound process? What are those processes? These are those processes which are mainly involved in input output operation rather than execution. So any request which comes from any input output device comes under input output bound process. So we have seen what is a long-term scheduler. Let us see what is a short-term scheduler. So short-term scheduler is a program that is provided by OS under the scheduling method which is used to select a process from RAM that is ready to execute and dispatch it to the processor. Okay, so basically it selects the programs inside the ready queue and it transfers them to the CPU for execution. So that is the job of the short-term scheduler. It is also known as CPU scheduler because it is actually transferring the jobs to the CPU for execution. Then comes what is medium term scheduler. So earlier I used the term swapped out. So medium term scheduling is a part of swapping. It removes the processes from the memory. It reduces the degree of multi-programming. The medium term scheduler is in charge of handling the swapped out processes. Let us understand further. A running process may become suspended if it makes an input-output request. So whenever an input-output device gets connected, it gives an input-output request, due to which a running process may be suspended. A suspended process cannot make any progress towards completion. In this condition, to remove the process from memory and make space for other processes, the suspended process is moved to the secondary storage. So when a process is being interrupted by an input-output process, that process gets swapped out. Okay, so that gets into the secondary storage. Okay, what is the secondary storage? It is our hard disk. This process is called swapping, and the process is said to be swapped out or rolled out. Swapping may be necessary to improve the process mix. Okay, so there should be a proper mix of output bound and CPU bound processes. So it enables a proper mix of these processes. Further, we can see if CPU completes the task, the program just exits from the CPU. Okay, or in other cases, it can also goes back to the ready queue depending upon the scheduling algorithm. We will see what are scheduling algorithms in the next video. Next, we have context switching. So when an interrupt occurs, then system or CPU will save the state of the interrupted process in process control block of that process. So whenever an input-output bound process comes or some other process actually interrupts the process under execution, the process under execution gets interrupted and it goes to the input-output waiting queue or to the secondary storage. So that process where one process is being interrupted and switched to another process, that is known as context switching. So what actually happens? The interrupted process, how does CPU get back to the interrupted process? Like a process is interrupted. Now how does CPU know from where to begin the execution? It will not start from the start of the execution of the process. So it will save the state of the process under execution and then will start from there on. Okay. So after this, the state for process to run next is loaded from its own process control block and used to set the PC registers and start the execution of those processes for which interrupt occurs. Okay, so the state is firstly saved into the process control block of that process and then that state is being carried over to the registers. Okay, where are the registers? They are with the microprocessors. Okay, so they are being stored in the registers. The process of saving the state of interrupted process and load the state of interrupting process is called as context switching. Okay, so when a process is interrupted, a new process comes. So this process of switching over the state is known as context switching. Obviously, too much context switching is not good. Okay, because it consumes some time unnecessarily. So context switching time is highly dependent on hardware, because the states of the processes are being saved in the registers. Okay, then during context switching, CPU will not be doing any useful work, so it is purely overhead. Next, we have the CPU scheduling and its criteria. Okay, in order to get written material for your ready reference and for your further reading and revision, do click on the link below. Do find the PDF file in the link below. Okay, so do visit the link below in order to get the PDF file and do join our Telegram channel for further discussion. Okay, and in case you like the video, then please do hit the like button and I wish you happy learning.